x plus 1 times x minus 2.
Awesome.
I mean, minus 3.
Correct. I knew what you meant to say. Okay, indeed. So then on the side, I have to write two restrictions. What are they again?
-1 and 3.
Very good. Notice what I do. Why did I write this? Why did I draw those bars?
Because it can't be those numbers.
Because it's undefined. Excellent. And if the function is undefined, of course the derivatives will not exist there. There is no discussion about that. I hope you agree, right? If the function doesn't exist, how can it have a derivative? Perfect. What do you think I'm going to do next? Well done so far.
Would you plug in the negative infinity and infinity?
You are on the right track, but we are running a clean ship.
Oh, make it just 1 over x minus 3.
Excellent. Good. So now, indeed, I would like to determine this. I would like to determine this. And I would like to determine the function value at 0. You realize that all this work is done even before I find the first and the second derivatives. I have to fill out my table with everything, x and y intercepts, limits left and right, limits at infinity. I have a lot of work before I get to the first derivative. Okay, so then let's start here. Limit of 1 over x minus 3 as x approaches negative infinity or infinity. What is the answer? Anyone?
It would be -2.
So what do we have to do first when we find a limit? Anyone?
To plug it in.
Okay, excellent. So please plug it in. I have $1 and I want to divide it so that I give a little piece of it to everyone on the planet. When I get to your door and I say, here, I'm at your door, I want to give you a piece of the dollar, how much will you get? I only have $1 for the entire globe. How much will you get when I get to you? I'll start in China and India. And by the time I get to your door, how much is left from my dollar?
Almost 0.
Thank you very much. Y equals 0 is a horizontal asymptote. Perfect. Notice one thing that happened here. This factor went away. So now note x plus 1 was simplified. Therefore, x equals -1 is not a horizontal asymptote, but a hole in the graph. So I write myself a note. Hole. The factor that stays is a vertical asymptote. The factor x equals 3 is a vertical asymptote, but the factor that went away, it will be a hole in the graph. Please plug in this function 0 and tell me what to write here. F of 0. Can anyone give us f of 0? Anyone? Alex, f of 0?
Negative 1/3.
Very good. Why do you torture me? Okay. Good. Now I need to determine these limits. Limit as x approaches -1 from the left of 1 over x minus 3. And limit as x approaches -1 from the right of 1 over x minus 3. Same thing with limit as x approaches 3 from the left of 1 over x minus 3. And then limit of 1 over x minus 3 as x approaches 3 from the right. Can anyone tell us this limit? Gabby?
Is it just 1/3?
Which number did you plug in to get 1/3?
0.
Why? I mean, how can I plug in 0 when it says x approaches -1 from the left? How can I plug in 0?
So would it just be 1 over -4 then?
Excellent. Well done. And the same thing here. So I write -1 over 4 and -1 over 4. Perfect. Great job. Okay, what about here? Anyone? Noor, will you tell us how much is this?
I'm not sure.
Michelle?
I'm lost too. I don't know.
Oh, so what, by any means, what do you think we're gonna do first? What do we need to do first in order to find this limit? Plug in 3. So what do we get when we plug in 3? The top is 1, the denominator is?
Yeah.
Good. So we know that then this is either positive infinity or negative infinity or DNE. Every time we have 1, for example, or any number over 0, it means infinity, negative infinity, or DNE. We called it no hope type of limit. So now, because it's 3 from the left, tell me the sign. With 3 from the left, what would be the sign? I know the answer now, but what is the sign?
Negative.
Very good. So this is negative infinity. And now here, same thing, the same answer. It has to be, it's a vertical asymptote. But I need the sign, but this time I come from the right of 3. What will be?
Infinity.
Indeed. That's it. Well done. Okay. That's it. I cannot squeeze anything from the function to learn about the function itself. This is it. I exhausted everything. I can only write here that y equals 0 is a horizontal asymptote, and I'm done. Finally, I can talk about the first derivative and then the second derivative. Of this, it's already simplified. I'm not going to differentiate this. There is no need. I will differentiate the simple one. And of course, you know me. I'm not going to differentiate that. I'm going to differentiate this. To which power?
-1.
Of course. I refuse to use the quotient rule if the numerator is just one number. I'm not going to waste my time. If it's x in there, then I have no choice. So then f prime of x, can anyone differentiate this for us? Shvam, would you like to try?
Are you doing it for x minus 3 to -1 or the original?
I didn't even copy the original, so we are here, right?
Yeah. Would it be -1
Excellent.
and then x minus 3 to the -2?
Awesome. Times the inner function prime, which is?
X minus 3.
Prime. Prime. How much is x minus 3 prime? Differentiate it. Very good. So this is it. Good. So back to, where's my page? Good. Is this ever 0? Is a fraction with a number at the top ever 0?
When the denominator is 0?
But we already said that when the denominator is 0, the fraction is undefined. So we already said that. If the numerator is 0, the fraction is fine. Only when the denominator is 0, the function is non-existent. So when is this 0? Not undefined. When is a over b equal to 0? When?
When
B
A
equals 0.
Right, exactly. Awesome. But can I make 1 equal 0?
no.
No. So this will never be 0. What about the sign? What is the sign of this expression? Always.
I had a question.
Yes. Don't forget your question, Rita. Hold on. So indeed, f prime of x is always less than 0. What does this say automatically about the function? That the function is always
Negative.
no, the function is not negative. When the derivative is decreasing, it better be. Yes. Yes, this is negative 0.25 and this is negative 0.33. And it's going to negative infinity. And it's going from infinity to 0. It has to be always decreasing. Yes, Rita, sorry.
Going back to the A over B thing, I always taught that if you divide anything by 0, it equals 0.
We're talking about A, not B.
But the question was when the fraction equals 0, right?
Yes, a fraction is 0 only when the top is 0, but the top cannot be 0. It doesn't have x in it. It's a number.
I think I understand her question. It's not when the denominator is 0. It's not 0. It's undefined because you can't divide by 0. So it's different than being 0.
Okay.
You can't divide by it. Does that make sense? So there's something actually being 0 and then just being undefined.
So those are two different questions then.
No. We found the derivative. The next step is we have to find the critical numbers. So I have to set f prime of x equal to 0. But it could never be 0 because the numerator can never be 0. A fraction is 0 when the numerator is 0. So this fraction can never be 0 because its numerator can never be 0.
Okay.
Is that better?
Yeah, I think I just mixed up being undefined versus equaling 0.
But undefined is a tragedy. And the tragedy happens or can happen at the denominator. We never ever stated restrictions for the numerator, ever. We only restrict the denominator because division by 0 is undefined. But 0 divided by 5 is 0. Is that better? Is that okay?
Yeah, I'm good.
Okay, so moving on to the second derivative. If it's not clear, let me know, because if it's not clear to you, it may not be clear to others as well. Okay, so here's the derivative. Now we want to differentiate again. Can anyone help? Let's say Brianna. We are different. We're differentiating this for the second derivative.
Would it be, hold on just a second. 2, and then in parentheses, x minus 3 to the negative third.
Good. Times the inner function prime, which is?
2.
How much is x minus 3 prime?
1.
Good. So this is then 2 over x minus 3 to the third power. Can the second derivative be 0?
No.
No, can never be 0. It's a fraction that has 2 in the numerator. 2 cannot be 0. Good. But what is the sign? And the answer, the question is not that simple. I don't know. But here's what I'm going to do. You don't have to change the function, but in order to discuss the sign, I'm going to write it like this. Because the sign of this piece is always what? The sign of this piece is always?
Positive.
That's it. So I'm not going to bother with it. This will give the sign. Excellent. Good. So to the left of 3, what is the sign? Plug in any number, not negative, including -1 actually. So plug in any number to the left of 3 and tell me the sign of this.
Negative.
Very good. So now plug in a number to the right of 3 and tell me the sign. Does this function have a max min? Does it have a max or a min? Does it? Anyone?
Oh, yeah, the min.
It can never have a min if the derivative never changes sign. If the function is always decreasing, the function cannot have a max or a min. Does the function have an inflection point? Anyone? Alex, what do you think? Does it have an inflection point?
I don't think so, because doesn't it need to go -0 positive or +0 negative to have an inflection point?
So if I thought for a moment that you were talking about the first derivative. So we're talking about the second derivative, correct?
Yeah.
Okay. So indeed, the second derivative changes sign from negative to positive, but the inflection point does not exist. The function is not defined here, and so its derivative is not defined. So if I cannot give you that point, there is no inflection point even if it changes concavity. It changes concavity, it's opening down between these two, and it's opening up between these two, but it does not have an inflection point. Great job.
Yeah,
Great job.
because 0 would have to be there, right, in between?
0 or undefined, but the function had to exist at that point.
I see. Okay.
Good. So now we are ready to graph this function. I only care about my table. Nothing else matters. The whole is -1, -1/4. So I'm going to take a bigger unit. So -1, -1/4. This is the whole, -1, -1/4 on both sides. 0, -1/3. And 1, 2, 3 is a vertical asymptote. And now let's see. Decreasing from 0 to the whole, opening downward at all times decreasing. So from 0 going through the hole and eventually approaching -infinity on the left-hand side of the vertical asymptote. On the other side, it's coming from +infinity, approaching. The reason why I didn't mention it, but I should have mentioned it, this is y = 0, but I'm not going to graph it again because it's already there. So from +infinity, opening up, approaching 0. All the time on the other side is opening down. It's going through the from y equals 0 through the hole to the y-intercept, approaching negative infinity on the left-hand side.